Okay, we're going to start on page 22. If you were not here yesterday, or even if you were, at the top, fill in the definition of the fundamental theorem of calculus. What that says is when we have the integral, the definite integral from a to b, we can find the antiderivative, which is the capital F, input the value of the b, subtract, input the value of a, and that gets you the answer to the definite integral. So for number one, finding the area, that means integral, of this function from 1 to 2. Our first step is going to be to do the antiderivative. Add 1 to the power, divide by the new power. And we put the values on the integral, the 1 to 2, on the back so we don't forget them. So we're going to input 2, subtract, input 1. Go to your calculator. So we get 2/3 minus negative 2/3 minus a negative is plus, so that is 4/3. So today we're going to practice the definite integral with the fundamental theorem of calculus with just a little bit more trickier problems. So let's start with number 2. Here's your choice. You could either do u substitution, since you have a function within a function, or because we're just squared, I think I would rather do the algebra of multiplying together and not have to do u substitution. So we've got the integral from 0 to 1, first, outside, oops, I have 2 pluses, inside, last. Let's combine like terms. Don't need that equal sign. Now we're going to do the antiderivative. Add 1 to the power, divide by the new power. Add 1, divide by 0 to 1. Okay, so we're going to input 1. I want to make this 4. It's less to right. Minus, and now I notice every term here has an x, so when I input 0, that's going to add to 0. Okay, with the 1s, we've got 16/3 plus 4 plus 1. You can use your calculator to get to that final answer of 31/3. All right, for number 3, I see an E. I need these formulas. All right, so this E formula will be given to you on your test. You do not have to memorize it. You don't have to put it on a note card. But the issue with number 3 here is my power is not plain x. So I have no way about it. I have to do the u substitution. So we're going to say let u be 2x, which means du dx is 2. So when I come to fix up my integral, that gives me e to the u dx. So I need to replace dx. I'm going to isolate dx here. So I get 1/2 du is dx. All right, so now we've got the integral from 0 to 3 e to the u times 1/2 du. One half carries down. The e to the u, well, that has an antiderivative of itself. But we didn't start with u. We started with u being 2x. So I have to put the 2x back in. Now I can do the fundamental theorem of inputting the top number minus inputting the bottom number. This is e to the 6th minus 1/2 e to the 0. Well, e to the 0 is 1. Oops, not minus. I get 1/2 e to the 6th minus 1/2. That is our exact answer. All right, let's try a few more. Number 4. Well, I first do this down here. Have to get this out of the denominator. And I'm going to add 1. And, oh, wait. Getting ahead of myself here. Sorry. Whew. Now that I'm going to do the power rule, I add 1, divide by 0. That's not going to work. That's a no. Impossible. I don't see this 1 over x on my formulas down here. Hang on. Yep, nope. That's not one of the special rules that we're going to be given. Can you think back? What had a derivative of 1 over x? So if y equaled this, then y prime was 1 over x. It's the ln of x. So the antiderivative of 1 over x is ln of x. So with the fundamental theorem, that gives us ln of 2 minus ln of 1. This has a base of e. So e to what power is 1 is 0. So our final answer is ln of 2. All right, number 5. To do number 5, I need that square root as a power. So the coefficient carries down. Add 1 to the exponent, divided by the new exponent. I'm going to need more space. Actually, dividing by this fraction, let me update that. That's the same thing as multiplying by the reciprocal, which very conveniently helps me simplify. So now, input the top number, input the bottom number. These will actually simplify nicely because this denominator of 2 is a square root. So I know that I can square root 4. It's negative 16. Ooh, bad color. I can do the same thing with 1. I know the square root of 1 is 1. So negative 16 plus 2 is negative 14. All right, let's try 6. I see the integral of sine here. So let me get rid of the rest of these. But it's not a plain x, it's a 9x, which means I need u substitution. So I need to replace the dx. So isolating dx, and multiply both sides by 1/9. All right, I get 1/9 du. So now I've got the integral from 0 to pi, sine of u times 1/9 du. The 1/9 carries down. Antiderivative of sine is negative cosine. I got to put my u back in. Now we can do the fundamental theorem. Input the top number minus input the bottom number. Make sure your calculator is in radians. So cosine of 9 pi is -1. That's negative 1/9 times -1 minus negative 1/9 times cosine of 0 is 1. So this is 1/9 plus 1/9, and we get 2/9 as a final answer. All right, last but not least, number 7. There is no such thing as the quotient rule in antiderivatives. But because it's a monomial denominator, I can think of, let me write it as each term over the denominator. Then I'm going to simplify. I need a negative power. On the x's here, this is a 1. So I can subtract powers. I think I'm going to need more room. All right, so now we can do the power rule. Coefficient, there isn't one, so let's add 1 to the exponent divided by the new exponent. Coefficient carries down. Add 1 to the exponent divided by the new exponent. Okay, let's fix up all these dividing by fractions. Let's multiply by the reciprocal. And then let's simplify. 5 reduces with 5. All right, we're going to input 1. So this whole value minus input 0. Okay, well, when I input 0 here, that's 0. And I got 3. When I input, okay. So this whole last term is 0. Good, I don't have to write that. Now, the cube root of 1, because see this denominator is the cube root, is 1. So let's just type it. So I get 1 to the 2/3. So this gives me 3/2 minus 3. It's 1 to the 5/3 if you want to double check it. Is also 1. So now we've got 1.5 minus 3, negative 1.5, or negative 3/2. Okay, so the rest of your practice today is page 24 and 25. On the test, there are 3 steps I'm going to be looking for. Step 1, the antiderivative. I want to see your power rule, or whatever the antiderivative rule is. Step 2, I'm going to want to see the b value plugged in minus the a value. For step 3, you can use the calculator and write out the final answer. So those are at least the 3 steps you have to show for every fundamental theorem of calculus problem.